right, so we got another math question here. It says, how many lines of symmetry does this shape have? And it's a big capital Y.
All right, I can take that one. Did that have, it'd be helpful if I could just pull that up, but I don't know if that's, do you know when that was sent?
Yeah.
It's okay, I can redraw it if I need to, but.
So, should be subject help.
Okay. That's why I wasn't finding it, because this is an image with the text in there. All right, so we want to know how many lines of symmetry. So I'm just pulling this up. But first, let's talk about, as I'm pulling this up, what symmetry means. Symmetry just means if you drew a line that, in a sense, you could imagine it like being folded over onto itself over that line and kind of looking exactly the same. So one of the things I kind of found interesting about symmetry, and I always tell my students, is have you ever heard about, like, there are studies showing like why people find other people attractive? Have you heard this?
I have heard this, the more symmetrical a person's face is,
the more attractive
they are, right.
So Denzel Washington is considered to have one of the most symmetrical faces in Hollywood.
So is Halle Berry.
Halle Berry too? Because if you literally drew a line like straight down their face and like had a mirror and copied this side of the face onto this, they would look exactly the same.
You know those Apple, on the Macs, the photo studio or photo booth? Yeah, photo booth, that's what it's called. So they have one of those things where it cuts you down and it like reflects you, and so then you can put half of your face together with your other half. And most people just don't even look like themselves when they do it.
I should do that because my nose was broken, so it's a little like crooked right here, and I kind of wonder if it would look like a weird.
It might.
Maybe I'll try that. So anyway, that's kind of an interesting thing about symmetry and how we kind of use it and we don't really think about it, but subconsciously.
It's pleasing to the eye.
It is. That's a good way to say it. Very pleasing to the eye. So when we look at this letter Y here, think about, and I'm going to give you a different object. When we talk about lines of symmetry, think about if I did a line like this and a line like this, and these are considered the lines we're going to think about for symmetry. If inside of here I did, say I did a rectangle, you could imagine that if I thought about this line, imagine if you were to, like we just talked about, cut this side out and fold it, and replace the other side. Imagine like I took a mirror and flipped it over that line and replaced the other side. Would it look exactly the same or not? And in this case, it would, right? It would say, I mean, if I mirrored this over and copied it, it would look exactly like this side. And the same would go for if I looked at this right here. Let me do this. This line right here, and wanted to think about if this is a line of symmetry. Again, think about if I were to, another way to think about this, if I were to take a mirror and place a mirror right where that blue line is, and kind of mirror that one side over to the other, would it look the same?
Yeah.
And in this case, it would too. And these are not the only lines of symmetry we can look at. We can also talk about diagonal lines, something like this. So I actually have another line of symmetry here, where if I were to...
Is it a square?
Let's call it a square.
Let's call it a square. If it's a
That's
square,
a good
then
point.
that's symmetrical. That's not perfect square then.
Let's call that a square. And actually, I'm glad that Becca said that, because in geometry, it's really important. I mean, I can argue that none of these are symmetrical, or none of these lines of symmetry work if I can't be 100% sure that the measurements are the same.
But that's a common one that people like to say. I remember teaching this in middle school. If you have a rectangle and they want to cut it right there, and they want to say that's a line of symmetry because it's the same size piece, but it's not, because if you folded it, I mean, think of if you took a piece of paper. Like if you took a piece of rectangle and you were to fold it in half, like fold it at that line of symmetry. I'll even just show you what it looks like. It's obviously not symmetrical. You can see they don't.
It's a really good example.
Little mountain range.
But it looks, it makes it look, you know, when you have a rectangle and you draw it, you know, down the diagonal, it really makes it look like they're symmetrical because the pieces look equal. They look the same, right?
And I'm going to kind of steal Becca's idea here and use that same idea. Like we say this rectangle has a line of symmetry here. because if I fold it right there, it's exactly the same on both sides. Or like we said, if I fold it this way, same, right? So that's another really good, I think, visual way to think about it. It might be hard to imagine.
Like
a mirror.
folding over.
Yeah. So when we look at this letter Y, we're asking how many lines of symmetry do we have? In this case, if this were a square, I would have another line of symmetry right here. And I think that would be it, right? 1, 2, 3, 4 lines of symmetry. But with this other shape, let me rewrite square, I'm only seeing one line of symmetry. Right? That line of symmetry would be if I were to go straight down here. And Becca, if you see something else that I'm missing here, let me know. Because sometimes it can be a little, that's not a very good line. Sometimes it can be a little tricky to see these, especially, I can't move it. Maybe I'll move the other figure instead. Especially with figures that, well,
They just don't want to line up.
I know, you get the idea. Especially with kind of odd shapes, or like I wouldn't even say odd shapes, but like the
Just
square
irregular,
rectangle,
yeah.
right? Where it's really easy to think that you see a line of symmetry, but it doesn't actually exist. When we look at this value y, or this figure y, the only line of symmetry we have is straight up and down. So that line could be called x equals something if you're on a coordinate plane. But you really have to kind of try to visualize and imagine this. If I were to draw a line horizontally like this, that clearly looks different on top and bottom. If I reflect it over, it's going to look a lot different. And you can kind of visualize, or you can draw lines and play around, like that's not going to work.
Yeah.
Nothing here is going to work. So a lot of different ways to play around with this.
There are actually little mirrors that you can. I had them when I taught middle school. Yeah, little mirrors that you can use to test it. That you lay down on the paper, and then it will reflect what's on one side onto the other, and so you can see, whether or not it is symmetrical, because it actually shows that reflection.
You're going to have to help me find that, actually. I think it'd be really helpful for my geometry class when we talk about this.
Right. Okay. You got it.
We can also talk about, really quick, something called rotational symmetry.
Oh, and that's a tricky one.
Yeah,
that is really tricky to see.
Very hard to see. What's a good figure to try? I can do a triangle.
A triangle is a good one. I was thinking of like a star.
A star? Yeah, I think I like that. I can't really draw a star very well here. I'll just do it like this.
That one's tough to teach too.
It really is, because
it's easy to get the folding thing sometimes.
And it's sometimes, you know what? I'm not going to do a star. I'll just talk about this triangle really quick.
Okay.
If we assume that this is an equilateral triangle, since you reminded me, we got to be really clear. Basically what this is saying, and like Becca said, it's hard to see this, but can I rotate on here? If I were to spin this around, I don't think there's a rotate option. If this were an equilateral triangle, I could turn it, and I could bring this point right here kind of up to the top. I don't know if that's confusing.
Yeah.
But you can imagine if I were to just rotate it, say 60 degrees, then it would look exactly the same. And if I rotated another 60 degrees, it would look exactly the same. Again, like Becca said, it's a little tricky to see, and you kind of have to play around, get used to it a little bit.
Yeah, but essentially if you flip it or rotate it, flip is the wrong word.
Right.
Rotating it, it is the same thing.
Right.
So.
Yep.